Hi everyone, welcome back to tutorial 3 on for loops. Today we're going to go through the operation of for loops, which allows us to do iterative processes for a set number of times. So for this, what we're going to do is we're going to create a new script. And for this script, let's first off save it. We'll save this as test script 2. And what we're going to do is up here in front, I'm going to do my clear all CLC just to make sure that everything is in order. So next, let's define the goal of this code. It is to determine velocity based on distances and times. So next, we're going to list out our givens. First off, we're going to say that we're given that the displacements or distances traveled are 0, 2, 10. Now this is new notation. What this is equal to is 0, 1, 2, 3, 4, all the way up to 10. This is a shortcut way of being able to write this. The longer version of this shortcut is actually to include a center number between two colons. What this does is it defines a beginning value for the limit and an end value for the limit. And then the number in the middle tells you how it's incremented. So as you'll notice, it'll go from 0 to 10, and it goes steps of 1. Now, if you have a different value, and let's just look at our command window for an example, we can do a more complicated system. We can say instead of an increment of 1, we want to increment it by 0.5. In this case, you definitely need to include the center value. Otherwise, the default would give you 0 to 10 incremented by 1. But if you actually want to step this by steps of 0.5, you will include that center number there. Now, if you include a number that is not divisible by the final number, such as 0.33, you'll notice that the very last value provided is not going to equal the last value in your range. In fact, what will happen is it'll start off at the starting point and step based off of this middle number and get as close as possible to that limit value. So in this case, the last value before going over 10 is 9.9. So coming back to our code, let's take a look and see what we have. So we're going to do this in steps of 1. So I'm going to remove that additional 1 and go with the default value. And we're going to say that this was recorded every 0.5 seconds up to 5 seconds. And so let's label these so we know exactly what we have. These are distances that were recorded in feet, and these were recorded at the times written in seconds. Now, what we would like to know, so this is our unknown, is velocity. We know that velocity, which we'll denote as v, is equal to the change in distance divided by the change in time. What this means is if we do an example, for the very first point, so v1, this would be equal to the distance at t is equal to 0.5 seconds minus the distance recorded at 0 seconds. And let's put a bracket just to designate that, divided by time at 0.5 seconds or 0.5 minus 0. That would be how you would solve for the very first velocity. This first distance divided by this first time. Now, in order for us to do this, we need to be able to step through and get information from a step ahead as well as at a current time point. So because of this, what we're going to do is we're going to use something called a for loop. A for loop is going to allow us to cycle through a series of calculations for a set number of times. We have our vector d which has a whole series of displacements or distances, and we have the times at which each one of them was recorded. Okay, so based off of these, you can see this as almost a table. And let me move these over so we can see an alignment. So these can be seen as the values that were recorded at each of these time increments. Oops. And so what we're going to do is we want to make sure that we're going to be able to then figure out what is the increment based off of this equation. So the for loop has a very basic syntax. It begins with a for and ends with an end. And what is to be cycled goes in between the two. We have to be able to tell the for loop how many times is it going to cycle through this set of calculations. So if we look at this, we're going to be calculating 1 difference, 2, 3, 4, 5, 6, 7, 8, 9, 10 times that calculation. So what we're going to do is we're going to say for I equals 1 to 10, we're going to do the following. Now I is what we call an index. So for us to denote this, this is going to be our index. And this tells us, keeps track of how many times we have done the cycle. Now what are we going to calculate? Well, we have our calculation right here. We have that V is equal to the change in distance over the change in time. Well, how do we represent that? Well, if we write this out in a basic form, just looking at the first two values, we would have 1 minus 0 divided by 0.5 minus 0, right? Because this 1 minus 0 is the difference in these first two values, and the 0.5 minus 0 is the difference in the corresponding time. Now we have to look for the pattern, and that's one of the most difficult parts to for loops is you need to find a general pattern. Well, if we look at this, we start at index 1. If we look at how we have all of our vectors denoted, this would be column 1, column 2, 3, all the way up to column 11. So as a result, one way that we can do this is that we say I plus 1 minus d of I divided by time at I plus 1 minus time at I. Now, visually being able to see this may be tricky at first, and so I suggest, writing it out on a piece of paper. That way you can keep track. But if we plug in a sample value, what we'll see is that if I is equal to 1, d will be I plus 1 or 2. So this will index the second entry of your vector. So in this case, d2 is 1. d of 1 is 0. That's exactly what we wanted. Similarly, with the time, we would get 0.5, and the time at 1 would be 0. So that's perfect. Now, you can go ahead, and I would definitely do the practice of convincing yourself that this works for the entire length of both of these vectors. Now, keep in mind the single use of a single digit is possible when you have a vector that is only a single row or a single column. When you use a matrix, it's you're going to want to be a little bit more explicit about which exact entry. But because we have something that's very simplified in terms of these vectors, we're going to keep it with this single value entry. We'll do some more complicated indices later on in other tutorials, but for now, we'll start off with the 1, 2, 3, 4 type of indexing. So that's it. That is the only calculation we need to do. But here's one thing. You'll notice that when we plug in I, this will end and it will start over again. We'll go through this process again and it will overwrite what V is. To give you an example, let's run this as is. So you'll notice that nothing appears here in the command window, and that's because everything in this script has been suppressed. So if we look and we just type V, you'll notice that you get 2. And so that'll make you wonder, well, why am I only getting one value if I is equal to 10, meaning that it went through the entire cycle? The reason being is that it was overridden every single time, and so it didn't actually save what the value was at each step. So this is an opportunity for you to create a new vector to save it. So one efficient way is to create an empty vector at the beginning of your for loop. So here you'll notice that V is equal to empty brackets, and this is to create an empty velocity vector. What this will allow us to do, then we will start indexing every single entry to correspond to the index of the for loop. So if we run this again, we go back to our command window and type V, you'll notice that now we have a value in every single entry. In this case, this shows us that we have a constant velocity. That's great. So what this means is that we've been able to calculate it at every single point in time. This is one way that you'd be able to do this. And so this is perfect. We also can check what the size of the vector is, and it says 1 to 10. So this lets you know what is happening at every single point. You'll notice that this time is different than the length of time that you have here, but this is considering that you would have started with initial velocity of 0. You can go in and manually input a velocity of 0 to set what that time is at time 0, because this first value actually corresponds to the first difference at 0.5 seconds. There's a very easy way to fix this vector to include that initial point. We would go in and say V is equal to, open bracket, 0, comma, V. What this will do is it will take a 0 and then add on or concatenate the vector V onto this. And so you'll see here that now we have these two vectors. And if we look at time, we have 11 points. And if we look over here at our V, this also has 11 points. So this starts at 0, 0 at time 0 and jumps up to 2 seconds and jumps up to 2 feet per second by the time we hit 0.5 seconds. So this is an excellent way of being able to show how you would be able to use a for loop to be able to build up a vector and reuse one mathematical expression for an entire system. So for this next example, what we're going to do is we're going to assume that we don't have just one set of distances and time that we are trying to figure out velocities for. Let's say that there was a race and there were several racers, and now you're in charge of getting all of the velocities over the time span, and they were recorded at the same time t. So let's create a new test script, and we'll call this test script 3. And we're going to have a similar setup. So I'm going to pull a little bit of the same information that we had previously. Okay, so we still have our unknown velocity, but instead of just having only one distance, we're going to have a few more. And I have some already pre-generated distances that we're going to use. Okay, so here we have this whole series of 4 different racers, and we have their times, and they're all recorded at the same time, and we need to figure out the velocity. Now, we could go through and cycle through each one of these and figure out each of the velocities, but what we're going to do is do something a little bit more creative and try to create a function that would plug in this information automatically for us once we drop it into a for loop. So what we're going to need to do is we're going to need to create a function. So let's move this over to the right hand side. This way we can create the function. So let's name this velocity. And we're going to go over here to script 2 to grab what we had as our basic information. All right, so remember when we have this, we need to make sure that the function is going to be labeled just as we would for the file name. Okay, so in this case, what we have is we're going to have a function that has an output v, which is a vector, and it has going to be velocity, and it's going to take an input of distance and time. Just to add this information onto our function q, we're going to say that we have an d distance and t time as our inputs, and our output will be velocity. Okay, so this gives us a bit of information. So I'm just going to create a break, that way we can view where we are. Now, what we have, and going back to our previous script, this is the equation that we previously used. And we had a for loop that went through and divided everything for us. So actually, let's just copy the whole thing. So in this case, we're actually going to have two for loops, because what we're going to do is d distance and t time, these both are going to be vectors. And so what this means is we need to do this over these lengths. Now, to make this generic, we want to make sure that, in this case, all of these are a length of 10, but may not necessarily be the case for another race. You may have a situation where more than the first 5 seconds was recorded. So in this case, what we want to do is we're going to make this generic for future use. And so to do this, you'll notice that 10 represents the 1 minus the length of the vector. Because if we look at D1, and if we come over here and type this in, let's clear all. CLC D1 is equal to 0 to 10. We can see here over in our workspace, it has a length of 11. And so in our case, our index goes 1 minus that. So what we're going to do is we're going to increment this to the size of D, comma 2, so that's the number of columns, and we're going to subtract 1 off. And so based off of this, this should give us an indexing from 1 to 10 for our example. Next is we need to be able to create the vector. And so in this case, we have our vector v, and we're going to need to create that again. So v will be equal to this empty vector. So empty vector. And from there on, everything's going to be the same. So we have created our function. Now, how is this going to appear on this side in terms of our test script? Well, we want to be able to track every single one of these, inputs. And so, for example, we would not want to have to go in and say, velocity D1 time, velocity D2 time. We could technically do that, and I'll show you what this could look like. You could go in and say V1, put in D1, and you go in, you copy this again, V2, D2, and etc. But this is actually quite tedious. I know in this problem we only have 4 racers, but if you think about a process where you may have a lot more racers or a lot more data to include, this is not the most efficient means. So what we're going to do is we're going to create a single displacement matrix, or distance matrix. And so in this distance matrix, what I'm going to do is I'm going to take, and we're going to do these vertically, I'm going to line these up and put all 3 of these vectors in. And so just so we can see what this will look like, let me copy this. Well, actually, we can rerun this right as it is from here. You'll see right here, we have created this matrix, which has all the values running from t equals 0 all the way up to t equals 5 seconds. So that's perfect. If you wanted to make this even more useful, you can even change this and say you can have distance is equal to, and maybe copy this, where you could even put the time in there as well. And just to show you, so in this case, this first column would be the time versus this first matrix only has distances. That's up to your preference. In our case, we're just going to assume that we're going to just have one matrix that has distances in it. So let's suppress that. So we have this information. So what we're going to do is we're going to create our for loop. Now you can keep your indexing any way you like. You could keep this as I. Generally, I like to change my variables for each of my for loops just to make sure there's no interaction between them. So in this case, for this matrix, we are going to run this function 1, 2, 3, 4 times because we're going to take each column, run it through this function, and pull out the velocities. So we're going to run this from 1 to 4. Now we have the velocity. Now we know that this is going to run through the function velocity, which takes a distance and a time. Now the distance, we want to take a single column at a time. We're going to do racer 1, 2, 3, and 4. So we need the distances. So in this case, we're going to take all the rows of the jth column, right? So in this case, the first column will be racer 1, second column would be racer 2, etc. The time is consistent because we said they were recorded all at the same time. Now, in this case, we also want to produce this velocity such that we can create a similar matrix that we did here with the distances. And so we're going to follow a similar indexing to the distance matrix. So we're going to say all rows of the jth column from this first cycle will be equal to this output. I'm just going to suppress it so that we don't see it every single time. So that's it. So what it should do is it will say j is equal to 1. It will come in here and say, well, velocity is going to use the first column of the distance matrix and the time vector to pull into this function. It will run through the function just as it did previously. It will take all of the di plus 1 minus di minus 1, do the differences, divide them out, and build this vector for you. It will then come out as an output and build your column of the ith index. So let's see if that works out. So let's hit run. One thing I want you to note is that when you do hit run, this automatically will save your script, but it is preferable that you do save your scripts as you go, just in case something happens. All right, now right off the bat, you see there's a subscripted assignment dimension mismatch. And so it points us to the function. So let's click on this. So noting this, we go back in and we look at our function and see what could possibly be the issue. And I know what it is. The reason is when we first created this function, we were basing it on the fact that we had row vectors. We are now in the situation where D has column vectors as input into the function. So we want to go in and make this notation that this is a column vector, and our time currently is still a row vector. And we need to come in here and change this to a 1 because size d comma 1 will give us the number of rows in the vector d. So perfect. So let's save that and let's try again. This time you'll notice that there was no errors. So perfect. Now let's see what our results are. Excellent. So in this case, you'll notice that now we have 4 vector columns creating this matrix V for which we now have the velocity for all 4 of the racers. We can add on zeros as we did previously to this matrix using a similar method of concatenation. So we can go in and say V is equal to, and knowing what we learned from one of our first tutorials, we'll do zeros, and we're going to do 1 row, 4 columns, and we're going to add this onto our matrix V. And so as a result, you'll see that here we have 0, 0, 0, because all of these racers started at 0 velocity and then went up to the velocities as shown. This is a great way for you to use a for loop to be able to call a function, as well as utilize a for loop within a function or in any means of a script to be able to do a mathematical process iteratively. Key thing is, for for loops, you need to have a definite number of times that this is going to occur. So in this case, we knew that it was 4 times due to the number of columns. And here we knew the number based off of the incrementing that we did with our practice calculation. So with this, I wish you luck with your for loops and hope to see you on another tutorial.